So our next speaker that we have for today is Mark.
All right, thank you. Okay, this is a very different topic to the last talk, which I actually really enjoyed because I've got a little toddler, so this is like the stuff underlying this is all me struggling with all the stuff you've just heard about. So I guess I want to start by questioning what is a writing machine. It's probably a term that you're not really familiar with. It's just something I'm trying to find a framing for a lot of these ideas that aren't really very clear. So a lot of this is a process of discovery, and I kind of use the term writing machine just to summarize a whole bunch of different ideas and techniques and technologies I'm going to talk about, which are all directed at generating text without direct human authoring. So that basically means there's no author tapping on keys or dictating input. What it doesn't mean is that there's no author involved. So the author's still there, they're feeding inputs and parameters into a system, maybe responding to feedback rather than sort of etching out their ideas and their thoughts as marks on the page. I guess a big feature of writing machines is they kind of have to obey these two principles or sort of follow this structure of novelty, so that they need to have a kind of source of randomness. They need to be a combination of this randomness, novelty, and constraints, so they need to be patterns. So we want to be surprised by the output, but we also want to see a certain form and shape that's more predictable, so this is where repetition and patterns come in. And I guess like this stuff doesn't have to involve code. So the very first writing machine in the form of a computer is this ridiculous Victorian thing called the Rickerby machine. And it was designed to generate Latin verses. It's sort of like a weird steampunk pokey machine that it could only display a limited line of text at a time. So people playing with it had to have a notepad and quickly write down each bit of text that it generated and sort of rush to copy it before the next line came along. And I think it randomly played God Save the Queen in some sort of crazy Victorian thing. I mean, fascinating stuff. The Victorians are always sort of on the verge of computing. Yeah, I think the history of this is too long and detailed for me to really go into, but there's a lot more precedents than you might think. A lot of this stuff really dates back to the very earliest forms of computing. So what do we look for when we're thinking about using writing machines or even building them? What properties do they need to support in order for us to recognize their output as writing? So texts that come out of these machines, we want them to be well-formed. So they have to be syntactically, grammatically correct. We want them to be comprehensible. So it means that they make sense. They're readable and coherent. We recognize them as not just a stream of characters, but actually statements and language. And then we want them to be meaningful. So not only do we want to comprehend the output, we also want the output to actually mean something. So conveying ideas and saying something that's worth saying. And then finally, we want these machines to be expressive, so that they can not only convey something that makes sense, but also have mood and tone and theme and stylistic elements that reinforce the meaning of the text. Also, I guess there's a huge area where these methods are actually actively used in terms of apps, games, and bots. And these things are actually a bit harder because they need to do all of the stuff that I just described, but they also need to be aware of where they're operating, and they need to be responsive to inputs. So they need to know facts about the world or accept input and then change in response to that. But I guess a good question to ask is, do we even need to address these problems? This stuff sounds really, really hard. So meeting the criteria for a generalized writing machine that I just outlined is extremely difficult. Nobody has really cracked it in a reusable sort of general way. So it's definitely worth considering if we can avoid that complexity, if we can avoid doing any of this work, and how that might impact on our methods and our results. So if we're generating poetry, for example, maybe we don't need to care about meaningfulness. Maybe it's okay just to spit out stuff that's kind of associative. And maybe we don't even worry about it making sense and even being syntactically correct. So we could just generate ASCII art, which is kind of a form of concrete poetry if you sort of squint your eyes and think about it. It's a contrasting end of the spectrum if we want to generate automated reports or summaries of events, things that are based on facts that we feed in as data. Maybe we don't care about expressiveness and all those kinds of elements of mood and tone and theme. Yeah, it's always really good to simplify the problem. And I guess it's sort of a good starting point is to ask, yeah, this is a really hard topic, but what if we can just make it simple and just start by not caring about all that detail? So I want to propose another way of thinking about these writing machines that avoids a lot of those difficulties, avoids trying to solve all aspects of generating coherent language at the same time. So I think like the practice of building writing machines allows us to reconnect with older traditions of novelty and constraint. So these examples, so the Chinese hexagrams, the tarot cards from Europe, things like this are in many ways like a forerunning sort of examples of generative writing and emergent narratives. But in this context, I actually want to look at these in a slightly different way. I want to look at it maybe in a more mundane context where these are fortune-telling devices in cultures that they were once a meaningful part of people's daily lives. And they weren't really seen as sort of artistic or sort of generative praxis or whatever we kind of pretentious art words we want to use to associate with this kind of work. They sort of served a similar cultural purpose to apps and the tracking stuff and Fitbits and that kind of stuff that we use day to day. So it's kind of another way of looking at this. So although I introduced the topic by outlining these sort of sweeping and epic computational challenges, I want to reinforce that there are not barriers to entry. Like this stuff can be day to day and really straightforward. And many of these methods and ideas you can just pick up and start using. And so this is where I want to start, just looking at well-formed syntax and a few little ideas and techniques that we might come across frequently in our day-to-day work. But actually, if we put these together, we find that it's a sort of these elements of natural language processing which we can string together to make these larger and more interesting pieces. So let's start with something that maybe a few of you have seen or have come across as a problem in your apps. So we have a piece of data. In this case, we've got an entity called a post. And in order to actually generate a bit of text that describes that entity in terms of its position in a list, so we need some label in the UI or something that kind of gives it a bit of context for the user. And if we just shove the data into a string, we get this. And it's not quite right because we don't, in English we need nouns to be countable nouns to have agreement. So one post selected doesn't really make sense. So this naive approach we get into trouble with it pretty quickly. So here's one way of solving that problem. Who's done this or kind of seen this? Yeah. So we stumble across these kind of things. This doesn't involve any natural language or generative stuff. This is just, I'm going to stick this thing into the string and then move on. Not great. Well, at least it's great for us as programmers. It's not great for users. So here's another way of solving that problem, which basically hard codes the grammar rule, manually handles the condition, and it actually has to construct these strings on their own. So it's an in-place transformation. And I think you can quickly see how this is going to lead to problems. So yeah, it solves the problem. We're grammatically correct. We've got the agreement that we want now. But we have a new problem, which is that we're hard coding these grammatical rules. And these if-else statements are going to quickly proliferate. So if we want to start using more nouns and we want to do larger and more structured stuff with the text that we're working with, well, yeah, this is going to be spaghetti really quickly. So those of you who use Rails, well, this is not a problem for people using Rails. And I think a lot of you already know how you go about doing that. So what I've done is here, I've pulled out the view function in Rails that basically exists to solve this exact problem, because this is a very common problem in building apps. So this is actually a simplification of the code, but this is roughly the kind of thing that we would write for our templates like all the time. So you can see how it treats the agreement as a rule, but it can be applied to any noun. And the way that that works is there's, so active support has a thing called the inflector. Using these standalone, there's this other library called Inflecto, which some of you might be familiar with. I think the Ruby Object Mapper project was using this for a while. So if you're doing stuff outside of Rails, there are tools and techniques that you can use. You don't have to bring in the whole of active support. And so this is what the API looks like. So it's a nice, simple way of corresponding to English grammatical rules, these kind of weird and irrational things that we have to deal with when we're outputting text. And this is really nice, right? So let's look at a related problem. So we can quickly see what's wrong here. So we just don't say, we don't eat a apple or eat a orange. So due to the phonetic patterns that are etched into English language over centuries, we have to cut those vowels with a consonant. So the naive generated text is just not going to sound right. So again, we need a kind of grammatical rule to make sense here. And really, this is just ridiculous, okay? The other example, maybe not so much. I've seen that. Just do not do this. You just can't. But there's a great gem that solves this problem too, in a very similar way to the inflector. So these things are called indefinite articles, and we want to refer to a noun in its position grammatically. So we can reach for the gem that encodes that rule. And here's a really straightforward example of generating that sentence. So we pick a random fruit, and then we build a string, and we just use the library to give us the correct grammatical transformation. And yay, we get a decent result, and we didn't have to program those grammatical rules directly. Yeah, so this is a really interesting kind of area. But you can see it's kind of just stringing these individual rules together. So having to deal with language at this very low level, it gives us a lot of affordances and allows us to do a lot of things. But in order to really think about the bigger picture of what we want to do with writing machines, we need to think about how do we get from syntax to things that make sense and have meaning. And so here, I think this is probably the trickiest part of the talk. But it's hopefully where I can save you months of painstaking research and confusion, because I've sort of been through this over the past few years. And I want to try to provide a framework for thinking about these different tools and techniques of generative writing that kind of allow us to move beyond strings and look at different ways that we can represent human terms in terms of like human ideas about writing. So not just chaining Unicode together, which is awesome, but we actually need to build on top of that to create meaning and narrative coherence. So here is a model for thinking about generative writing. There's no universal way of representing writing. Aside from Unicode, which operates sort of at a sub-syntactic level, so very low down, there's no way that we can structure data about a text that tells us everything about the text, everything that we might understand and think about in terms of what the text means and what it tells us and what it gives us. So one way to think about these problems is to look at generative writing as a series of layers, starting from the representations of language at the very atomic level. We're talking about phonetics and characters and Unicode and letters, and then moving up through words. Words kind of bridge that, because words bridge syntax and meaning. And representing meaning is about, say, sentences and paragraphs. And then we move even further up to think about, okay, how are those paragraphs structured at the larger level? How do we put these sort of longer, meaningful and associations together between the paragraphs and sentences? And that's where we have conventions from the history of books around passages and chapters and sections. And then at the very top, we've got the idea of narratives, which is a really abstract concept because it's not really something that you can encode directly into the strings that you generate. It's a more meaningful, more abstract human thing. So another way of thinking about these problems is that it's not so much about the levels, like the exact ideas that we're trying to represent, but more about the direction that we're moving. So whether we're going up or down those levels in terms of how we're thinking about language and how we're representing the language. And depending on which path we take, we end up with very different ways of doing generative writing. So we could start with structure. We could start with plots and themes and narrative tropes and all that stuff on that awesome TV tropes wiki, which I love. And figuring out how to turn that structure into text by sort of working down, so chaining these things together and then figuring out, okay, now I've got this meaningful narrative thing, or this plot, this list of events, how do I turn that into readable text? Or we could start from the opposite end of the spectrum and go bottom up, where we can take massive corpuses of existing text and sample them and actually generate, sort of statistically generate writing. And you'll see, hopefully you'll see that these aren't just kind of methods and techniques, but they're also philosophies of authorship. They're ways of using computers to generate words that actually have a lot of kind of trade-offs and consequences from the approach. So the structural way is about templates, it's about top-down organization, putting formalisms that we understand about patterns in, and trying to handcraft the results, whereas the statistical approach is really about turning text into data, into numbers, vectors, and then operating on it mathematically. So that is, and that's a kind of prevailing approach in the industry right now. You look at some of the stuff that Google's doing, for example. And here, I want to focus primarily on the structural approach, because that's where my own research and methods that I'm working on are about. But I want to take a little dive into the statistical stuff because it is really fun. Unfortunately, I can't show any of the really crazy stuff that Google was doing with being able to crossfade and move between texts, which is sort of an emergent form of writing. But I think in the next couple of years, you're going to see that more and more. But let's start with something straightforward that maybe some of you already played with. And like, it's really an infinite source of amusement, I think. So it is quite fun to look at. And that's Markov chains. So this is really widely known. It's really commonly used. Who's played with Markov chain generated text, or sort of done Twitter bots and stuff using that? Yeah. So this should be reasonably familiar to you. So let's just explain how it works with a simple example. So we can take a bunch of sentences, break them up into individual words, and then we can work out the probability of words that follow from a preceding word. And so to generate text, we can then pick a starting word. So in this case, we might want to pick I. And then if we've got I, we've got a 75% chance of am and a 25% chance of like, based on the frequency of those chained words in sentences that form our corpus. And we can move on and on and on. But the key with Markov chains is that the steps have no memory. So you keep moving along and randomly select the next word, but you never really go back in context. So they can lead to some really weird and interesting outputs because of that lack of memory and context. So I'll show you an example that I threw together for this talk. So instead of taking words, what I did here is actually took strings of characters. So on the Māori dictionary, I basically got a whole large word list, and I chopped it into chunks of text, basically splitting it into 2-character long strings, and then chained them together. So this data structure is called a bigram. There's actually like a concept called n-grams, which are like arbitrarily long words, but as soon as you get longer than 1 or 2, you pretty much end up reconstructing the exact source text. So 2's a really interesting number to play with here. And you can see this is like complete nonsense, but it retains the underlying sort of lexical feel of the language. So you look at it and you think, this is Māori, even though these are not words, these are just like gibberish. So that's really interesting. This is how a lot of like fantasy name generators and alien name generators and stuff work. And here's another example. So this is from a corpus of Wellington street names. So maybe you can imagine these being like weird little places in Ara Valley or up on Mount Vic or something. But sometimes Markov chains, when you don't have careful constraints on them, turn into a real mess. So this is from the same street name corpus of Wellington streets. And it's really funny and like just, I mean, if you were working creatively with this, it's just unusable really, unless you deliberately want this weirdness. And so this is what Markov chains are famous for, the spam emails, the nonsense gibberish stuff that you sometimes see in weird games and bots. So yeah, and if I stumbled across these on street signs around Wellington, I'd be like, whoa, what's in the water of the city council? All right, so if you're interested in playing with this more, this is a really fantastic gem that actually reads from the Twitter API and generates text based on a parody of like someone's Twitter account. So you can use it to make a shadow Twitter bot that follows you, and basically regurgitates your Twitter posts, but in a weird kind of sort of random, sometimes profoundly funny, sometimes just utterly like not even comprehensible way. So a lot of people are having fun with this. You'll sometimes see their username with an underscore ebooks or a bot. And then if you're looking for general libraries in Ruby to play with this kind of thing, search Ruby gems. There's like a ton of them. Heaps of people have done this. This is one that I found that seems to have better docs. Like a lot of them are kind of like really early versions. But you know, or play around and just make it yourself. Like like I said, this is really an infinite source of fun, but it's limited in how far you can go with it. So what I want to talk about now is move on to actually thinking about structural methods. So as we looked at earlier, these instead of the statistical kind of randomness, we're looking at encoding forms and shapes of language into our generators. And generative grammars are one of the most powerful and popular and common ways to do this. So, and traditionally in computer science, grammars are used for parsing, but in this context, we can flip that around. There's no reason why they can't work the other way and actually produce text with the exact same ideas. So what is a grammar? In essence, it's a series of rules for producing strings. So yes, we are operating at the string level, but the powerful thing about grammars is that because these rules have names, we can actually encode the representation of meaning into our structure. So even though that doesn't appear in the output text, our generator has that understanding of meaning. So it leads to much more coherent and meaningful output than, say, the statistical randomness does. The trade-off is that it also involves a lot more effort and creativity of authoring and takes a lot longer, which you'll see in a moment when I show you some examples. So this approach has been around for a long time. People always assume that it's going to go out of fashion, it's going to be out of date and replaced with all this amazing word vector and machine learning stuff that Google's doing. It'll be totally superseded, but that just never happens. And these grammars are still here, and they're still like a primary method for generative writing. So let's look at an abstract example of a grammar that can sort of, I guess, show us how we can, with these very simple tools, produce coherent text. So this is a breakfast grammar, and it has rules for a bunch of spreads and rules for, I don't know why I called that baking, because toast isn't really baked, is it? But oh, whatever. It kind of makes sense. And naming things always hard. So baking with spreads. So we've got a string that combines. We take those elements and we generate these sentences. Toast with Marmite, croissant with jam, toast with Vegemite. So let's expand on that. So let's replace jam with a symbol as a rule instead of a string, and then add another rule so we have variations. You'll see here it's kind of similar to the examples we showed before about indefinite articles, and there's a bit of repetition here, but we get the results that we're after, and we can just keep adding these symbols and keep building these grammars to generate more and more complex and intricate texts. So you get amazing control over the output with this thing, but the trade-off is that you've got to do a lot more work to get there. So I want to show you how to dive down into these ideas with Ruby. So Calyx is a gem that I created. It's something I've been using over the last couple of years. It's kind of an accident, and it's just been growing and getting out of control. So I kind of assumed when I first started here that there would be a lot of gems already available to do this, but I found that they actually weren't. And so I hacked together a little fragment parser and an abstract syntax tree tool. It was just for my own little purposes, and then it just kept growing and growing and growing. So eventually I realized, hey, this could be useful to other people, and so I turned it into a gem. So let's take a look at transforming the breakfast grammar into a Calyx grammar that we can actually generate real text with in Ruby. So you can see the same rules are, I've actually expanded this a little. So there's a new rule now for Marmite and Vegemite. And I think this is generally a good practice when you're working on these things. When you have a list of nouns, try to keep them as nouns. And you can also see doing the jam in the same way means that we no longer have to repeat jam, and we can actually have jam flavor could turn into, say, a list of fruits, and so we could use it in multiple places. It's really powerful. So the key idea here is that when you have more than one option in a production, so those are the things on the right-hand side, with the rules that kind of define it. Calyx will pick randomly from that list of arguments and generate the output text. There's a template substitution syntax that you use. So we are in Ruby, so we've got to use strings, unlike the more abstract grammar concepts, which have really cool syntax. We just have to transform it into this format. And this works really well. So let's take the earlier example. I found that on larger text projects, it's really useful to have an affordance for transforming strings in place. So again, we get the advantage of just putting a list of nouns in. We don't have to label them or mangle them with kind of particle words around them. So this is really great, right? And like these are the fundamental techniques. They can scale up to arbitrarily large and complicated and messy projects. So now that we've seen what grammars do, let's share a few examples from projects. So these are things that I've been working on. This is called Tiny Woodland Bot. It's an attempt to create a more gentle, kind of refreshing environment on Twitter, where things can be pretty hectic and quite uncomfortable at times. With like Twitter has sort of gone off on a tangent in the last few years, and so I like this idea of like being gentle and making this kind of thing. And it was also a great way to look at could I use emojis in Calyx. And so this is the grammar. It's a tiny grammar that powers a tiny woodland. And you can see there's something interesting here, which is new from following from the previous examples. And that highlights the feature that Calyx has of weighted probabilities. So you can see here how I've weighted the points that turn into emojis so that there's more trees and foliage and fewer flowers and critters. So this is really simple and fun. But let's look at larger and maybe less fun, because this is actually really painful to write. So this is a sample from a larger project that I did in 2015. It's called the Game Book of Dungeon Tropes. It's a 50,000 word generated novel, which is like a 1980s style like pick-a-path adventure. This fragment shows a grammar for generating like a boss type figure, like a dragon. And it's a ridiculous dragon. It seems very obsessed with like insulting the reader in a really lame way. And just this is how the novel works. It just has lots and lots of these little pieces with these kind of single grammars, and then it composes them all into a larger text. And so here's another example which shows more variation in terms of parts of speech. And this builds kind of a quest-style narrative. So yeah, you can imagine like this is a lot of fun, but it's quite hard to write. So if anyone has any ideas for making this authoring experience easier, I'm like really open to suggestions there. It's totally an underexplored field, so there's heaps of opportunities here. All right, so now that we know a little bit more about generative grammars, let's go back to our representations and keep moving up the layers. So we're thinking about meaning now. We want to start thinking more about narrative and how can we compose narratives that maybe aren't represented directly as text. And so yeah, we can use grammars to represent narratives, but the problem with using the grammars, as we've just looked at, is that they generate strings. And it's not ideal to use strings when we have kind of concepts like plots and characters, because if we end up with this sort of complicated piece, we are going to have to think about reparsing the strings and then turning them back into data, and it just seems really messy and scary to me. And there is actually a far better way to represent narratives, so I'll cruise through that, and I'm not going to go into as much detail about the APIs here, but hopefully you can start to see some of the ideas and techniques. Narrative graphs are the primary tool that I've been using to represent these concepts, so plots, characters, story events. So we need smarter data structures than strings, and graphs happen to be a really straightforward, well understood, and useful tool there, particularly when we're dealing with things like relational things. So a little refresher on directed graphs. We have a pretty visual kind of structure that it's much easier to explain graphs when you look at them. It's a little bit more tricky when you try to explain them in terms of set theory. But basically, we have a bunch of blobs, so they're usually called nodes or vertices, and then we have links between them, which are edges. And that's all. So that's what the data structure is. There are various ways of representing it in computers, but we want to think more about modeling at this level. So Another gem that I created for working with graph data structures and narratives is called Momentous. It's kind of an in-memory graph database thing, which is again kind of an accident. Let's just get on these weird side tracks and go down these rabbit holes and end up with these things. But I've been finding this is really, really useful for building these graph structures and actually starting to model the narrative ideas in a far more coherent way. So when I started off, I was trying to do everything in grammars, just ran into a lot of problems, and I've had far more success with this. It's all still a work in progress, so I'm not going to dive into the API because there's still a few things that I'm working out, but I will show you the output and give you some of a sense of how this work happens and how narrative graphs work. So these are some narrative graphs from my gamebook project. They model encounters with traps and with enemies in the story. So it's kind of like a Dungeons and Dragons-y thing here. But you can imagine flow charts like this can be used for so many different elements of storytelling. And the great thing about these is that you can consider each one of these graphs as a little mini story, and you can compose them together or transform them or manipulate them. And so you can build up a huge library of story events and story structures in this way. And it's far more flexible and powerful than anything I've come across in this area. But that also could be because I think in terms of graphs. Like I'm not really a database person. I'm more of a graph person. So that's my worldview in terms of software. So here's an example of the Momentous API from those previous graphs that we just looked at visually. And this is the story fragment of taking damage. And we just see it's a way of slotting these nodes and edges together, building up a little template, which we can then reuse. And we can layer things over the top of that shape. Because we don't have to do it each time, right? We can treat these little graphs as templates. We can clone the basic shape and then just use it over and over again. And this is another example. So it's a snapshot of a generated novel that I'm currently working on. It's a sequel to the Dungeon book, and it's in space, right? It's traveling through star systems and planets. And I'm building it based on rewriting and splicing chunks of the narrative graph and over and creating sort of new structures at each turn, which is actually really similar to the grammar concept. In fact, one of the ideas in this area is called graph grammars, a way of transforming these in the same way as we transform strings. And I'm hoping to, if I finish this Momentous library, it should support these graph grammars. Because I'm finding this is a really flexible and powerful way to model stories because I can think about it in small chunks and then have these huge things come out that I never have to deal with the huge thing. So diving deeper, like if we actually want to turn this into writing, into text, into strings, each one of these nodes might have to join into a grammar, and that grammar can generate paragraphs and sentences, and so the story can be composed using multiple moving parts. So that's a bit of a snapshot of my research and my work in this area. I kind of want to zoom back now and conclude just by thinking about, we've gone through all of these methods and we've seen these interesting ways of generating text and creating weird stuff, unpredictable stuff and repetitive stuff as well. So after going through all this, like why are we doing this? Like why bother? What's the point of writing machines? So let's think a bit more about motivation and purpose. So one very obvious motivation is when we want to create large volumes of text that would be complicated and messy and time-consuming to maybe impossible even to manage. This is actually how I got started, which is Phil actually in his introduction briefly alluded to that. So in 2014, I had been working on this novel manuscript for years, and I had a lot of loose material around the edges of the story that led me to the idea of exploring the story as an app. And so I thought through emails and documents and fake web pages, I could allow readers to kind of inhabit the desktops and phone screens of each character and see the world through their eyes. And I thought I was completely compelled by this idea. I thought it was great, and then quickly came into the sort of had to face the reality of to do something like that effectively, it couldn't all be hand-authored, and I needed a lot more content to make the fake desktop experience feel continuous and cohesive. And that led me to wonder, well, what if I didn't have to manually write it all? Could I generate the text automatically? And so you've already seen some of the resulting work and accidents that have kind of come out of just me asking that question. and it sort of ended up consuming my life in a little way. But I think what's interesting and perhaps a little bit awkward about this as a motivation is that it's the exact same motivation that spammers have. So there's kind of a few weird ethical things in there. It's an instrumental motivation. And for me, I think there are other reasons to focus on writing machines, more about creativity and art in terms of what we're trying to do. Exploring new forms of writing is huge. And for me, it's really all about intrinsic motivation. I do it because I find it interesting. And I discovered this kind of late. I wish I'd known and thought about it earlier, but it's never too late to find like a passion and get totally engaged in a new thing. And the thing about this as a motivation is it's not really about the end goal necessarily. It's more of a focus on the process and where that leads. And I think that's especially important in such a new area where we are still discovering the tools and techniques and ideas. I just briefly want to touch on something that kind of riffs off that, which is the Library of Babel, which is a really influential short story from the mid-20th century by Borges, the Argentinian writer. And so the Library of Babel is a terrifying construct. It's a universe-sized archive of all possible books that have 410 pages and use 26 letters. And it turns out this is a scale that's kind of incomprehensible. But one of the fascinating things about computational creativity and generative writing is that now, in 2017, we actually have the address space and the kind of power in random number generators that we can simulate this thing. So something that was a sort of source of existential terror in the mid-20th century is now a toy. So I think that's absolutely fantastic. I encourage you, if you find this interesting, to go online and search for, it's actually the website libraryofbabel.info, and a Canadian program has actually made this. It's kind of scary, but it's also kind of like a lot of fun because you just see the possibilities. And so, yeah, this is turning things that were impossible, that were thought experiments, into actual toys and things that we can play with. And finally, I kind of want to summarize this by talking about what is not a motivation, at least for me, and I hope for other people in this field. We do not want to replace traditional authoring and authors with machines. And so you see a lot of stuff in the media about AI and machine learning. A lot of it recently I have observed as really inflammatory, and I actually disagree with it like profoundly on some levels. Like I saw I think it was in The Atlantic recently, and an author basically said in 30 years' time, novelists are going to be over because machines are going to do it all for us. And if you look at the people working on this stuff, like we are not interested in that. That's not what we care about. And I don't think it's a productive or interesting or worthwhile thing to be doing. So I just don't know why people have kind of got this idea. So I think it's really in our best interest to reinforce and promote the idea that computing should be about supporting and enhancing human creativity, giving us kind of superpowers and allowing us to do new things and explore design spaces and narrative spaces that we couldn't previously. It's not about destroying and replacing what we currently have. It's about augmenting it. So we want to design and develop systems that kind of fight back against that dehumanizing view of AI and that dehumanizing view of kind of the future of work. And I know there's a lot of problems with ethics in the AI space at the moment, but what I really hope is that computational creativity can kind of show a different way of thinking about AI and a different way of thinking about these methods of automation that's kind of grounded in kind of love and respect for the history of human creativity and art. And so with that, I want to sum up. So thank you very much. It's been a great privilege to be here. I'm absolutely stoked to be able to share my research and ideas with you. And if you're interested or have any questions or forgot like something I showed and want to see it again, just hit me up on Twitter, or you can go to my website where I've got further notes and details about some of these ideas. So yeah, thank you.